let me say I have been already introduced. Andres Sandoval from the IEA, which is the acronym for the International Association for the Evaluation of Educational Achievement. So it's, we call it IEA for so it's shorter. And I'm, as Rafael said, I am the head of the Research and Analysis Unit in this organization. First of all, let me say thank you. Thank you very much. I feel really lucky to have been invited to come here all the way from Hamburg to Warsaw to talk about something that I'm passionate about, to talk about something that I love, to talk about something that I think is important. And I very much hope that at the end of this talk you will share with me what I think about what I'm going to be talking about. I'm going to be talking about the work that we do at the IEA. And what we do is large international, large-scale assessments, or if you want to say international, large-scale assessments in education. This is what we do at the IEA, and this is what I want to talk to you about. I'm gonna divide the presentation in 4 parts. In the first one, I'm gonna give a brief introduction about what is the IEA, what we do, what are our main studies, which are themes and pearls. I will go in detail to each of them in a minute. I'm going to tell you what kind of information we collect with these studies, with themes and pearls, and I'm going to tell you how we collect this information, and finally what we do with this information, ourselves, but also many other people around the world. What is done with the information that we collect. And in order to do that, I'm going to give you some examples. I'm going to talk in particular about 2 of the most recent publications of the IEA, which are the international reports for pearls and for themes, which is the last cycle that was released of the studies. It was in 2011. And then I'm going to talk about another publication, which is called the Relationships Report, which is, I'm going to talk a little bit about it, but it's themes and pearls have different schedules, every 4 and every 5 years respectively. But in 2011, as every 20 years, they happened at the same time. So that gave the opportunity to do some extra analysis, which is basically analyzing the relationships between achievement in mathematics, in science and reading in a wide range of countries. And finally, I'm going to tell you a little bit what has been done, what some countries are doing at the school level. I'm going to give you some examples of what people is doing with the information from these studies at the school level. What teachers are doing around the world, what principals are doing around the world with the information that we produce. So let's get started. As you may have heard, there are 2 major organizations doing international large-scale assessments in education, which are the IEA, the organization I work for, and also the OECD. And the OECD is probably more, they have the study that is called PISA, they have TALIS, they have PIAC more recently, and the OECD is the Organization for Economic Cooperation and Development. So this is an economic organization, so they don't concentrate on work solely in education, but they collect information about many other fields, particularly about economics. And they have 30 plus country members of the OECD. The organization is the one I work for, is the IEA, and we conduct themes, pearls, which are the biggest, the most famous ones, ICCS, which is a study on civic and citizenship education, and many others. We are launching right now a study on early childhood education. We are about to launch another study on English language in different countries. We have studies about computer literacy. We have studies about teacher training for teacher training for people who are studying to be mathematics teachers, and many others. No? The major activity of the IEA is the comparative educational studies. Also, we do lots of research and we do lots of training. So we said that we define ourselves as a research organization. And also in order to promote that other people use the information that we produce, we carry out lots of training activities. We have almost 70 country members or 70 countries represented in the association. The IEA is not an association of governments, it's an association of research institutes. In many countries, the institution that is member is the Ministry of Education. In many countries, it is they have some agencies, independent agencies to evaluate the quality of education. And in some other countries, we also have universities as an institutional members. And right now, currently, we have 69 countries represented in the IEA. Today, as I said, I'm going to be talking about teams and pearls. And before, let me tell you a little bit about the development of teams and pearls. The IEA initiated its activities back in the 60s, some years ago, and the major postulates of the IEA studies are that the quality of an education system should be measured by what students know. And what students know is related to characteristics of the system, which creates opportunities to learn. Those are very important concepts, key concepts for the IEA. And the third one is that assessment should be based on curriculum, curriculum driven. And this is the major difference that we have. You may wonder what is the difference between teams and pearls and PISA, for example. This is the major differences. Our studies are based on what students should know according to the curriculum. And we also take into account that what students should know is always influenced by the characteristics of the system, by the context, and by the opportunities that students have to learn. And in the case of PISA, they are testing skills that children will need to develop successfully in the labor market, something like that, basically, which is a different approach. This is, of course, they are an economic organization, they have an economical approach. We are an educational organization, we have an educational approach. So, teams, the origins of teams, at the beginning, they were separate studies for mathematics, and that happened in 64, 80, and 82, and for science, it happened in 71, and then 83 and 86. And then we put them together, and we call them the Trends in Mathematics and Science International Study, and this has been happening with this name and the two of them together, Mathematics and Science, since 95, then 99, 2003, 2007, and 2011, the last release. For pearls, the origins of pearls is a study that was focused on reading comprehension, and that the first one took place in 1971, and it was followed by reading literacy in 91, and then we put the name together, we put it together, we changed it, redesigned it, and we call it Progress in Reading and Literacy International Study, and that has been happening in 2001, 2006, and 2011. So what does pearls and teams measure? What do they measure? They measure achievement. They measure what students should know. They measure how they achieve in mathematics, science, and reading. And also they measure the student characteristics and learning environments. That is the family, the school, and the context. We think that learning happens in a particular context. So we are also interested about the characteristics of this learning environment. We are interested about the characteristics of the families of the students, about the characteristics of the schools, about the characteristics of the context, about the characteristics of the teachers, the teaching processes, and etc. So how to collect information? First, as I will talk about, we select a sample. And then we have a student test, which is like an exam, a test of mathematics, test of science, a test of reading, and we get some scores. We give them a mark, an achievement. And then we also have contextual questionnaires that we deliver to different kind of actors for them to provide the information that we require, the information that we want to get about the context and the learning environment. So, however, it is more complicated than it's been said. To begin with the sample, it has some challenges. No? The information has to be valid for the whole education system. So we cannot sample just the first 100 children who want to take the test, and then there we go. We have to make a sample in a way that information that we're going to collect is representative, is valid for the whole education system. Another thing that derived from that is that not all the students can be tested. That would be terribly impractical and terribly expensive and terribly time-consuming. So we have to select certain students. What students do we select in order for the information to be representative of the whole system? This is the tricky part. And the other challenge is that the students are nested within schools, and schools are nested within sectors or political districts or types of education. We have a nested structure. And what does it mean to have a nested structure? It means that the students who go to a certain school are more likely to be similar to each other than students that go to another school. If we have a group of students attending a public school in a rural area, they are going to tend to be more similar to each other than students going to a private school in an urban area. So that also poses some challenges for the statistical design, for the statistical analysis and for the sample. So what is the solution? We select a probabilistic sample, which means we know what is the probability of each of individuals that are part of the sample, what is the probability of being selected. We have a stratified sample, which means that we divide the population in strata according to the characteristics of different countries. Different countries have different strata. In some countries it could be private and public education because they are very different. In some other countries there's very minor private education, so this wouldn't work. But in some other countries we have boys and girls because they are in different tracks. In some other countries we have this tracking system with depending on the level of achievement of the students, they allocate them in different tracks. This could be the strata. And then depending on each country, we divide the population, the sample in strata. And then we have a multi-stage sample, which has to do with the fact of the nested structure. First, in TIMSS and Preschool, we sample schools, and then within the schools we sample a classroom, and in the classroom we test all the students that belong to the classroom, to the group that was selected. And well, this again is been said easy, but then it has consequences for the analysis. And the consequences is that we have to use special statistics to compute point estimates. For example, to compute the mean, to compute a percentage, we have to use special statistics. It's not that straightforward. It's not like we cannot use plain SPSS, put the numbers there and calculate the mean. No, we have to use sampling weights basically. And we have to use special statistics to compute the standard errors. Our estimates, whatever it is, a mean, a percentage, whatever you are calculating, your estimate is not going to be perfect. The only way for it to be perfect is that you tested all students in the population. So it is not. But you have to know how precise it is. In order to know how precise it is, you have to compute the standard error. And in order to compute the standard error, again, you need special statistics, special methods to do it. And those are the replicate weights. In this presentation, I'm not going to talk about these technical issues, but I will in the workshop that I'm going to be delivering after this presentation and the following days. It's just for you to give you an idea that how we do it and what are the implications for that. No? Apart from the sample, as I said, we have a student test. And the student test also has challenges. And the challenges are that we need different types of items. We cannot ask only multiple option items. We need different types of items. We need constructed response items. We need multiple choice option items. We need children, in the case of girls, we need them to read the passage and then answer some questions about what they have read, etc., etc. No? So the other thing is that if we want to test something like, this is the objective, as you may remember, to test whether students know what they should know at 4th grade, let's say, no? Whether they know what they should know about mathematics. In order to do that, in order to have a reliable report of whether they know what they should know, we would need loads of items. And for example, in grade 4, in teams, in mathematics, we have approximately 350 items. But the assessment time is limited. And also the children, you cannot sit a child and give him 350 items for him to answer. It's just not possible, because it would take him or take her 10 hours. So by the second hour, he would be just guessing, or she would be just guessing. And you wouldn't have a reliable estimate. So you cannot do that. So what is the solution? Those are the challenges. No? We want to do that. In order to do that, we would need 350 items. We cannot give 350 items to the children, and we cannot give the test to all the children. So we have to come up with solutions. The solutions are, in the case of you cannot give the exam to every children, as I said before, we do a sample. We select a sample. In the case that you cannot give 350 items to one single child, what we do is to assign the items to blocks. We form blocks, topic-related items, and then we construct individual test booklets from item blocks. We take the blocks and we separate them in different tests, in different booklets. We call them booklets. And we include there both the trend blocks, which are some blocks that were used in the previous release, so we can link the results from the from 97 to 2011, for example, and also the new blocks. And then we give different exams to different children. So, and then this becomes tricky, no? How come that you can have a test, a score for different children if they took different exams, and you can compare this score? First challenge, no? How do you do that? Because someone may have a easier test than one child may have an easier test than the other child. So you cannot just compute the percentage of correct items and that's it. You have to do something with it, no? There are different tests, so you have to do something to come up with a comparable score. And the second thing is, how can you tell how much this particular child knows about mathematics if instead of taking 350 items, he took only 30 items? So how can you give him a mark for mathematics or science or reading if he didn't took the full test? And then how can you compare if they took different tests? No? So what are the requirements, or how do we address that? Once we do that, once we give different tests to different children, and just a part of the full pool of items to each children, what we have to do is to keep the number of booklets to a minimum to begin with. Otherwise, the more the booklets, the more complicated. And then we have to use special statistics to compute the student achievement scores, which is IRT. Again, I'm going to be talking in detail about it during the workshop, but IRT is the item response theory, which is a method that is used to scale the data in a way that is considered the difficulty of the item and the ability of the respondent, so you can get comparable scores. So even children took different exams, you can scale the information, the scores in a way that they are comparable. So first challenge solved. So we use IRT and we have comparable scores. The second challenge is they only took one part of the test, but they need a full score. And the plausible values can be understood as possible values. So they took only one part of the test. So what we want to know is what they would have had, what score they would have had if they had taken all the items. How can we know what score they would have had? Well, we try to predict, and we try to predict that with the contextual information that we have, with the characteristics of the family, with the characteristics of the context, but also with the pattern of answers that he gave to the items that he replied. For example, if he replied correctly all the easy items, we can assume or we can predict that most likely the other easy items that he didn't took, he would have answered them correctly. And further on, we can say that if all, I'm of course oversimplifying, no? If all girls are better than boys in reading, then girls have a higher likelihood to have a higher scores than boys. And then if this particular child had his parents or her parents went to university, both of them, and he or she has his or her own room and a computer with access to internet, normally this child's got a specific score. So we use all this information to predict. However, the prediction is not going to be very precise, so that's why we have plausible values, possible values, and we have 5 of them. So we say a child with these characteristics, with the characteristics of this child, most likely would have this score, but could have had a lower score or a higher score. So because it's not as precise, we took 5 possible values, and we use this information together in order to produce a final score for each student. I have to say at this point that these scores that are produced for each student are not reliable enough to report at individual level, which means TIMSS and PIRLS and PISA and all large-scale assessments don't give a mark to every child who took the test, because the mark or the score that we would give them would be very, very imprecise and with a wide range of error. But the information is useful at the system level. When we group the information, when we aggregate information, we have very precise estimates of how a country performs, how an education system performs, how girls in one country performs, how children attending public schools in a country perform. So when we aggregate information, we do have precise estimates. The third part, we also, as you may remember, we believe that what children should know, it's depending or is related or associated with the context in which they are living and with the learning environment that they have. So in order to collect information of this context, we have contextual questionnaires. So what are the challenges? If you want to have relevant, useful, sound information, you have to get it from a variety of sources. You cannot ask the children about his teacher's teaching practices, because probably he doesn't know what is a constructivist or a traditional teaching practice. You cannot, many times you cannot ask children about their parents. If you ask a boy, a student in 4th grade, what is the level of education of your father, he may not know. Or where does he work, what does he do for a living, he may not know. If you ask the child whether he was stimulated with early literacy activities before he started going to school, he or she might not know. So you have to ask the parents. There are many questions that you have to ask the parents. You have to ask the teachers. And also you have to ask the principals, the school principals. There are many things that even the teachers may not know, or they have a different judgment about different topics, about school climate, for example. They might be different perceptions. But also the time for respondents to answer questions is limited. This is another limit. You cannot ask as much as you would like. You have a very short period of time. Otherwise, same thing. No? People get bored and information starts not to be trustworthy after a certain point. No? So what is the solution? We have a number of different questionnaires addressing specific areas. For example, we have a national and community context questionnaire, which is answered by the National Research Coordinator, and we ask them about the national policies in the country, what is being done in different topics, what is the age when students start going to school, whether pre-primary education is compulsory or not, whether there are policies in place for attending immigrant students, and so on and so forth. We have a curriculum questionnaire also that is answered by the National Research Coordinators, and they say what is in the national curriculum and how much does it match, for example, with what is in the test. This is important to say. We have many countries, 60 countries or education systems participating in teams, for example, and we cannot ensure that the test is going to cover all the areas in the curriculum of all the 60 countries. And we cannot ensure that all what is asked in the test is included in the curriculum of all the 60 countries. So there is a mismatch there. We try to keep it to the minimum, but there is a mismatch. But we also collect information on that. What is the mismatch? No? We have a questionnaire on the school context, which is answered by the principals. We have a questionnaire for teachers. We have a questionnaire for classroom activities and characteristics, and we also have a questionnaire for students. So we have a set of instruments that we deliver to different actors in order to obtain the information that we need. What are the requirements of implementing this strategy? Well, we have to have a proper selection of respondents, and questionnaires should not be too long or too complex. This is also very important. No? We have parents of all sorts. We have parents who have a post-grad education. We have parents who are illiterate, and then we have to come somewhere in the middle to have everyone has the chance to answer and everybody understand what is being asked, etc., etc. No? And then we have to select carefully who is going to answer these questions. Now, who uses this information? Well, I mean, if you think about it, in the IEA in Hamburg, in the Data Processing and Research Center, we are around 160 people working there full-time all year long. We have another 15 to 20 probably people working in the headquarters in Amsterdam. And in each of the countries that participate, we have a team of people who is working there. We have the people who go to the school to apply the tests. We have the people who put the information in a data set in the countries. We have the people who score the tests, the coders who are saying whether the open response questions are correct or not. We have people who clean the data. We have really a big amount of people working on that. For this to happen, it requires the effort of many people and also lots of money. So why do we do that? I mean, why to bother? Who is going to use this information? Well, this information is used very much by researchers, by people in universities, by academic researchers, but it's also used by educational policymakers, and it's also used by teachers and principals, and it's also used by parents. And my presentation today is going to be a little bit about all these possibilities. What are they for? They use them, but what for? They have basically three main functions. The first one is the benchmarking function. They provide comparable indicators on student performance and schooling practices across countries. This is very important as well. The information that we produce is comparable across countries. And also the student scores, the scores in the test are comparable across countries. So we can know which countries do better than others. And this is not only for the headings in the newspapers, this is for learning from each other. If we know what countries do better than others, then we want to know what they are doing, how are they teaching, how their schools look like, what kind of policies they have in place. We want to know all this information. No? And also schooling practices. We can also say, these schools do better, and at the same time we can say the countries that do better, all of them have, I'm just making up, no? All of them have a compulsory pre-primary education, or many of them, or most of them have a strong program for professional development of teachers. All of them, or many of them, have programs to train principals on leadership, or etc., etc. So all these kind of things we can compare and we can know from these studies. They also have an analytic function. They are used to suggest hypotheses about the relationship between student performance and factors that may have an influence. Or in most countries, or within a country even, teachers who use a constructivist approach to teach geography, their students perform better in science. And we can identify these kind of patterns. Now, what kind of approaches? We cannot say that a constructivist approach or a traditionalist approach is better than the other. But we can say for certain topics it is more convenient, or is most likely that this approach is going to work better than the other. We can say these kind of things. We can say, and this is there are many studies on gender gap. No? And say in what countries girls do better than boys, and in what subjects, and in which areas. And then if we find that there are gaps there, then we know that we have to do something to close these gaps. we can know to what extent poor students do worse than rich students. I mean, this happens around the world in all countries, but in some countries more than in others. No? We can see in what countries this gap is smaller and what exactly they are doing in order for this to be that way. We can see that probably in our country this gap is huge, so we know that we have to address this issue. We can have information about immigrant students, and we can see that immigrant students do, and this is a tricky one because in some countries they do better than the national ones, in some countries they do worse, but it also depends on the kind of immigrants that you have in the country. And you can find this information in the data set. You can see what kind of teaching approaches, what kind of school activities are enhancing the performance of immigrant students, and so on and so forth. We can also see areas where students have particular strengths or weaknesses. Teams and pearls, they have not only the full score for mathematics or the full score for science or the full score for reading. They have sub scales that measure different parts of the subject. In science, we have in mathematics we have geometry and we have a data display, for example, and we can see what area is we have strengths or weaknesses. And I will show you some examples of that in a minute. And they also have an inventory function. That is, they provide information about what people know and can do, and surplus and deficiencies. So this is just to know, to descriptive information, inventory information. So these are some examples, rough examples, of what people is doing with these studies. For example, the profiles on high and low achievement students can be constructed to identify predictors of high achievement and strategies for improving student chances to achieving high. You can split the sample that you have, and you can say these are the students who are the high performance students tend to have these characteristics, and they tend to attend schools with these characteristics, and their teachers tend to do these kind of things. And the low achieving students, they attend schools with these characteristics, and then you can identify, you can create profiles, and then based on that you can design policies to revert the undesirable gaps. You can also have profiles of effective schools. What are the good schools? What are the schools where students achieve better? What kind of teachers they have? What kind of activities they have? What kind of principals they have? What kind of leadership they have? What kind of extra school activities they have? What kind of students they have? And again, you can use that to design policies. You can also have, of course, profiles of teachers. Who are the teachers whose students are performing better? And who are the teachers whose students are performing worse? And there is you have lots of variation across countries. In some countries, teachers are very similar. In some countries, they are very different. In some countries, the teachers have to have a master's degree in order to be able or be allowed to teach in a primary school. In some schools, they just have to finish the primary school in order to teach in the primary school. So you have a wide variety. And then you can create the profiles. And then you can see, well, if in my country, this is the profile of the teachers that I have, and it looks very much like the profile of the not so good teachers in this other country, you know what kind of things you can change in order to improve the effectiveness of your teachers. And also about classroom resources and practices that can be compared across or within countries, and in order to find the most efficient ones. No? There was a famous study some years ago that was saying that for some students it's good to have a computer, and for some students it's better to have just a calculator, and it's cheaper. No? So you know how to allocate your resources in a better way. What is more convenient, to buy computers for all schools in the country, or to buy computers for some schools in the country, and different kind of pedagogical aids for some other schools? It's all these kind of questions can be answered with information that is provided in these studies. I have to say that all countries that participate in Teams and Pearls use this information as a tool for monitoring and improving the educational system, because they have trends and they can be compared across cycles, across years, we know whether one country is improving over the year or has been improving over the years or has been, or otherwise, is getting worse. And we have both cases. I'm going to tell you a little bit about that in a minute. But we have countries that have been constantly improving, which means that since '99, for example, the policies that have been put in place are having good results because the achievement of the whole country, of the whole education system is improving or not. We have also very interesting examples of countries who went for a policy, very strict policy for decentralization and accountability in schools, and then probably that was not the best idea because then the achievement started to decrease. We have many studies. No? We can learn from others. This is the objective of these international comparative studies. So countries monitor and they try to improve their curricula. And then we have 3 levels of curricula in the IEA studies. We talk about the intended curriculum, which is what is in the curriculum, what is in the documents, what we want, what is objective, what we want to teach to the children. We have the implemented curriculum, which is what is really taught, what we are really teaching to the students, and we have the attained curriculum, which is the performance of the students. One thing is in the paper, let's say 10 topics, but from these 10 topics, you only managed to teach 9, and from these 9, the students only learned 5. I mean, we have this division. No? And in the 3 steps, in the 3 phases, different things can be done in order to improve these 3 different kinds of curriculum. For example, and these are just some examples, the use of ICT in mathematics and science curriculum in Singapore. That's something that was implemented from the results of analyzing information from teams, or addressing regional and community disadvantages in Australia and South Africa. They knew that there were some socioeconomic gaps, but they didn't know to what extent. Then when you analyze the data, you can know, and then you can put in place the intended curriculum. You can change it in order to address these disadvantages. In Australia, Chile, France, and Russia, they are using their results for shaping the national standards. What has to be learned? What are the national standards? And they use these results to shape these national standards. For the implemented curriculum, in Hong Kong, for example, there was a program for supporting parents' role in children's early reading development. They realized that the early reading development, the early literacy activities with the children were a strong predictor of achievement later on in primary school. So they say, okay, let's start from the very beginning. And they put in place a program to involve parents to support the children's early reading development. In Iran, it was a program for emphasizing more complex cognitive skills in teacher training. They realized that was a weakness of their systems, of their teachers, talking about teachers' profiles. So they realized that was missing there, so they say, okay, we're going to modify our teaching training programs in order to reinforce this part that is currently weak in our system. In Armenia, for example, they were working with release items in schools, which is one of the examples that I will bring you today at the end of the presentation. The release items is, of course, the tests for teams and pearls are secret, are confidential. You cannot give them to everyone, because if you give them to everyone, they could practice with the test, and when the test comes, everybody has a perfect mark. So, but nevertheless, it's confidential, but it's not secret. Every cycle, we release some items for people to know what kind of items we are using, and also for legitimize what we are doing. No? And well, these items are being used by schools in some in Armenia, for example. In the US, it has been done before, and in Spain, they are starting to do it. And I will tell you how they are doing that. Well, I have many other examples. In Qatar, for example, they realized that related to the attained curriculum, I mean, it can be that the intended curriculum is very good, what is in the paper is very good, what the teachers do is very good, but the students are just not learning. And then you say, why? In Qatar, they realized that one of these reasons was lack of motivation. Students were not motivated. So what they do is put in place a program to introduce activities to improve student and parent motivation for education. And the reasons why the curriculum is not attained in different countries can be different. And depending on these reasons, you can implement different programs. And well, this is what they did in Qatar. In Singapore, they identify specific weaknesses in student achievement to provide better opportunities. So they identify, as I said, mathematics has several parts. So you can take it like science, reading, and mathematics. And then you can see that in mathematics and science you are doing good, but in reading is a weakness. So if this is the case, then you have to reinforce the curriculum in reading, because reading in turn affects or contributes to the achievement in mathematics and in science. For example, no? You can identify all these things with the education. In Austria, for example, they introduced compulsory year of kindergarten for 5 years old. That was not compulsory, and they realized that it was a strong predictor of good achievement later on in primary education. No? They realized that in Austria, the children who attended at least 1 year of pre-primary education, they were performing significantly better than the ones who didn't. So they say, okay, let's make it compulsory at least 1 year. So this is a way to prepare, to make the children ready for education before they come to the schools. They do all these things, they know all these things. They analyze the data and they have these results. But then what they do with their results? What they do with all these results? Well, they publish them. They put them in paper, they put them in specialized journals, they put it in policy briefs, they put them in national reports. We publish international reports. This is just a list of the publications with the IEA studies that were published in the last less than a year, in the last 10 months. As you can see, there are many people doing things with this information. All these things that I'm saying, all the things that the examples that I'm giving, someone is doing it around the world. We don't have time for reviewing all these publications by one, but if you have the chance, you will see that there are research teams, so there are people analyzing this information literally around the world, in many different countries. And the information is out there. This is also to say you don't have to reinvent the wheel. Many things have been already said, many things have been already researched, results are there, and then the idea is to produce collective knowledge. The idea is to identify gaps in the literature, and the idea is to address these gaps, to know more, to know better what we want to know. So, okay, that was the brief introduction, that at the end was not that brief. And I'm going to go a bit faster through the examples that more particular examples that I want to talk to you about. And those, the first one is related with international reports of Pearls and Teams 2011. This is unfortunately very small, but it's just for you to have a rough idea of how the results are presented. This is the list of the countries that participated in the study. In the middle here, you have the scale center point, which is 500 points. Teams and Pearls are reported in a scale that goes from 0 to 1,000, but this is a theoretical scale because no one gets 1,000 and no one gets 0. But normally it goes from 300 to 600 around. And those are the average for countries, for different countries. Poland, for example, got in Pearls 2011 526 points, and Poland is above the international average, which is the orange bar, and this arrow pointing upwards means that this difference between the average for Poland and the international average is statistically significant. If you compare Poland with the highest achieving countries, which are Hong Kong, Russia, Finland, Singapore, and Ireland, there is a considerable difference we have these countries got 571, the highest, and 558, the lowest of this group. No? But at the same time, you could compare Poland with Morocco or with Oman, and they have 300 points. So, and also, which is probably more interesting, is to compare Poland with the countries which are close to Poland, because probably they are more similar, or with the neighbor, geographically speaking, the neighbor countries, or countries that we know that have similar education systems. And then we could see, no? Yeah, probably you will know much more than myself about the characteristics and how is the Polish education system, but you could tell what other countries are rather similar, and you could see whether they are performing better or lower. No? Similar in the education system, but also similar in the macroeconomic conditions of the country. No? It's not a fair comparison when you compare Poland with Finland, probably because the infrastructure of Finland is superior, no? in many senses. No? But you can compare, of course, using statistical techniques, you can discount the effect of all these socioeconomic conditions and come with a fairer comparison. But this is just a rough, crude, brutal scores that you can be used to have an idea, no? How countries are performing. The horizontal bars are how the students are distributed within country. No? The black point is the mean, and then you have the lower achievers and the higher achievers in these bars. No? And as you can see also in some countries this bar is wider than in others, which means that the differences are higher in some countries than in others, and that also tells you something about the equity of the education system, for example. No? The wider the bar, the more unequal the education system is. So there are big differences between the low performance and the high performance. And all this information you can get with this snapshot, with this table. No? This is a table taken from the International Report of Pearls. No? The top performing countries, as I was saying, are Hong Kong, Russia, Finland, and Singapore. And this is they group them as the higher performance countries. And the students, it is said in the report that the average student in this country with high performance can read, understand, and interpret relatively complex information in stories and articles between 800 and 1,000 words. Because you may wonder, no? Okay, you told me that those are the high achievers, and they got 571 points. What does it mean? What does it mean by 571 points? Well, it means that the average student in these countries can read, understand, and interpret complex texts with between 800 and 1,000 words. Compared to 2001, in general, we had more increases in performance than decreases. More countries improved than otherwise. Compared to 2001, 10 countries increased their average performance. Colombia, Czech Republic, Hong Kong, Iran, Norway, Russia, Singapore, Slovak Republic, Slovenia, and the USA. And compare 2006 and 2011, only 4 countries recorded declines in these lapses. No? You know, in these countries, the countries that got worse in their average performance were Bulgaria, Lithuania, Netherlands, and Sweden. And then in both cases, in 2006, 13 countries got improvements, and only 4 countries got otherwise. No? They decreased their average performance. And in both cases, you may wonder, what exactly did they do in this lapse, between these 2 time points? What kind of policies they put in place? And then you can start analyzing the information and see what they have done, or what most of these countries did, and the ones who improved and the ones who got worse, and then you can design policies out of there. No? Another thing that you can do is the reduction of the gender gap. No? If people is concerned about the gender gap, the girls and boys, in almost all participating countries, and this is the international average, in almost all participating countries, girls had better performance than boys in reading, in Pearls. And there was a small decline registered in this trend. This has been diminishing. This gap around the world, in the international average, has been decreasing. And in 2011, girls got in average 520 points, and boys 504. Only 5 countries have no gender gap. There are no differences or no statistical differences. And those countries are Colombia, Italy, France, Spain, and Israel. This is the same kind of information for teams, grade 4. And we have, in this case, for example, contrary to Pearls, Poland got 481 points, which is below the international mean, the international average of 500. So in Pearls, Poland got above the average. In teams, mathematics it got below the average. And in this case, it has an arrow pointing downwards, which means this difference is significant, statistically significant. And then again, if you compare with the highest achieving countries, the gap is even wider in the case for mathematics. No? Singapore is the highest achieving country, got 606 points, and Poland got 481. Again, you have Yemen, which even had below the 300 threshold, and Yemen got 248 points. In 8th grade, Poland is not here, but you can also see that teams and pearls are carried out in 4th grade, in 8th grade. In 8th grade, we had more or less the same countries performing at the top. And well, the top performing countries, grade 4, are Singapore, Korea, Hong Kong, Chinese Taipei, and Japan. And in 8th grade, we have Korea, Singapore, Chinese Taipei, Hong Kong, and Japan. Just the order changed, but they are the same countries. No? All of them, and this is something that was in the newspapers, all of them are East Asian. And then all the people is going towards the education system of the East Asian countries. What are they doing good? What kind of things can we copy from them? This is what you can do, what you tend to do when you see this kind of results. As you can see, there are considerable differences among the countries with highest and lowest performance. It's also important to say that in 4th grade, 22 countries scored below 500 points, which is a good number of them are below the international average. And in 8th grade, 27 countries were in this situation. No? So the gaps between high and low achieving countries are wider in teams than for pearls. We also have more improvements, more countries improved in 4th grade, but it was not the case in 8th grade. In 8th grade, we had more countries who got worse than the countries who improved. In 4th grade, of the 17 countries with comparable data, 13 countries recorded increases, and only 3 recorded decreases. So this is the same pattern that we found for pearls. But in 8th grade, of the 25 countries with comparable data, 9 countries improved and 11 countries got worse. This is the trend is not so good for the 8th grade countries. Other kind of things that you can do with this information is to check what is the role, to test what is the role of preschool education. And there you have a graph here where you have a question in teams which was asking whether your child, this is for the parents questionnaire, attended preschool education and whether he or she had been there for 3 or more years, less than 3 years, but more than 1 year, 1 year or less, or did not attend. And this is again the international average. What you have in the dots or in the vertical axis is the score points in teams, the average score points for each of these categories. So the average student who did not attend pre-primary education got a score of 457. And the average students who attend preschool education for more than 3 years got 507 score points. So there is, of course, there are important differences in coverage, but on average, students in 4th grade with more years of preschool education tend to have higher mathematics achievement. We have the same information for science, teams science. The other one was mathematics, this is science. Poland in this case was with 505 points and there is no arrow pointing towards or downwards, which means the difference with the international mean is not significant, which means Poland performed at the international average. And again, you can compare with the top performing countries, sorry, or with the lowest performing countries. No? For 8th grade, again, Poland is not participating or did not participate in 8th grade. But let's see, the top performing countries in 4th grade was Korea, Singapore, Finland, Japan, Russian Federation, and Chinese Taipei. And in 8th grade, Singapore, Chinese Taipei, Korea, Japan, and Finland. Again, it's dominated by the East Asian countries, but not only. We have some other countries there in the top performing countries. Again, in this case, there are considerable differences with the highest and the lowest performers. In 4th grade, 18 countries were below 500 points. In 8th grade, 24 countries were below the international average. Again, we have more increases than decreases in performance, and this is particularly in the case of grade 4. In grade 4, we had 17 countries with comparable data. 8 of them reported increases, and only 1 reported a decrease in the average score. In 8th grade, of the 25 countries that we were able to compare, 11 reported increases and 6 reported decreases. And again, you can see, or you can check what are the countries which are constantly in all subjects across all cycles getting improvements, and you can make a profile for them. No? We have the case of Slovenia, which is a not very big country, very small country, not very rich country. So I think it's an interesting country which in most cases has been improving from cycle to cycle. And we also have the countries which are constantly decreasing their average achievement. So you can have a good topic for analyzing the educational policies in these two groups of countries. Another thing that can be done is to analyze the home educational resources. This is an index that is formed by the educational level of the parents, the numbers of books at home, and the presence of support materials for learning, which is their own room and a computer with internet. And you form an index with all this information. You summarize it in one number, and then you can see that this information, you divide the information, and you have students with many resources, which are 12% of the students around the world reported to have many resources for learning at home. Some resources was 67%, and few resources 21%. And then we can see that the students who reported to have few resources perform lower than the students who report to have many resources. So this is a trend, clear trend across the world, across countries and within countries as well. So let's have a look at this one. This relationship report includes information only of the countries who applied TIMSS and PEARLS, as I said before. In 2011 happened at the same time, but not all countries applied the TIMSS and PEARLS to the same students. Some of them applied to different samples. For the countries who did apply the two tests to the same students, we produce an extra report, which is the relationships report, which is comparing the performance in mathematics, science, and reading for different countries. No? This is an edited volume with 4 chapters. Chapter 1 is the profiles of achievement in mathematics, reading, and science, which is an interesting one. I will show you some graphs. The other one is the impact of reading ability on teams, that was a question that was posed since many years. No? Whether when you test mathematics or science, the fact that the students are poor or strong readers has an impact on their mathematics test. No? Probably it's not that they don't know mathematics, it's that they didn't understand the question. Or it's not that they don't know geography. The problem is that they didn't understand, or they were not able to read and understand the question that has been asked. And then we have another chapter which is on effective schools in mathematics, reading, and science. And this comes together with all the literature on school effectiveness. They took a model from the literature. They applied the same model to all the countries for which we had data, and they show the results. No? And also we have another, which is the effects on home background and academic achievement. All questions, we hadn't had the chance before this data was released to analyze this question across the 3 subjects. And this is an interesting methodological chapter as well, because they use the structural equation models, which are very well made. I'm going to be talking briefly about the first 3 chapters. Those are the profiles. And this is what I was telling you. This is Singapore, which is the country with the highest score. And in the triangle, you can see the percentage, the dark green triangle shows the percentage of students reaching the high benchmark in at least one of the subjects. And the light green is when the percentage of students who reach the high benchmark in the 3 subjects. As you can see, the triangle in the inside is the same size. And you can see, for example, that in Singapore, around 50% of the students reach the high benchmark in the three subjects, in reading, mathematics, and science. The dark green triangle tells you the percentage of students who reach the high benchmark in each of the subjects. No? So in mathematics, it was almost 80%, almost all. I mean, the majority of the students in Singapore reached the high benchmark in mathematics. But in reading, it was about 60, about the same in science. No? So yeah, in the three subjects was 54, in reading 62, in science 68, and in mathematics 78. So you can see that the strong point of Singapore is mathematics, and the weakest point is reading. So this is a nice way to tell people in Singapore, they are already the best performing countries, but if they concentrate now more in reading, they are going to be even better. Because as you will see later on, this reading achievement, reading ability also has an impact on the other subjects. For Finland, we have something similar, but in this case, it's interesting to see that their strong point is science. It's not reading, it's not mathematics, it's science. And that tells you something about the country as well. No? You can say that 40%, which is the closest country to Singapore, only 40%, less than half, got a Borsila, a good number of them, had all students reaching the high benchmark in the three subjects. We have for Russian Federation something similar. In the case of Russia, the opposite, and there the strong point is reading, and the not so strong point, the weakest point is mathematics, which is quite the opposite to Singapore, for example. But Russia is also a very good performing country, and one of the countries that has been improving across the cycles. No? And then we have Poland. There's a big difference. In Poland, only 12% of the students reached the high benchmark in the three subjects. But, for example, reading, almost 40% of the students got high benchmark, which is interesting because almost half, well, close to half of the students got the high benchmark in reading. So the strong point of Poland is reading, and the weakest point is mathematics. So again, this is something for the policymakers to know and to do something about it. Okay, now there was another one. This kind of studies is important to carry them out with this information, because you can legitimize, you can provide evidence to say that there is a trend, that this is really happening, to confirm patterns, to confirm theories, to confirm hypotheses. So this is what it was done in this chapter. What was done was to divide the items in low reading demand items, medium reading demand items, and high reading demand items. Students were grouped in three groups as well. They divided the students, the distribution in terciles. The top 33%, the medium 33%, and the lower 33%. So the upper tercile are the strongest readers, and the lowest tercile are the poorest readers. And then basically what you do is to cross this information. No? Low reading demand items and the reading demand of the items, and how strong students are in reading. And we do it for mathematics and for science. So these are some examples. The first example is an item example of a low reading demand. So as you can see, it's just 23 times 19 equals, so they don't have to read much actually to answer this question. No? Actually, they don't have to read words to answer the question. We have them an example of an item that is a medium reading demand, where there is a text that they have to read and understand in order to be able to answer. And the text says, some of the materials below will burn and some of them will not. Put an X in the box next to the materials that will burn. So you have to understand that in order to continue. You may know that water will not burn, but if you don't know what burn is, then you won't be able to answer the question correctly. So, but you have to read. This is the thing. You have to read a text and you have to understand it. And then an item example of a high reading demand is includes a text to be read, a text to be understood, and also a graph, data display. No? Apart from reading the words and understanding the words, they have to understand the graph. in this case says, the graph shows the number of students at each grade in the Pine School, and then you have grade 1 to 6, and then the number of students on the vertical axis. And then in the Pine School, there is room in each grade for 30 students. How many more students could be in the school? This is a high reading demand item. You have to understand, you have to make sense of the graph, then you have to do the maths, and then you have to answer correctly the question. Once you have that, you can produce this kind of graphs. And this kind of graphs, what you can see is that with the circles, you have the upper reading tercile. With the triangles, the middle reading tercile, and with the squares, the lower reading tercile. And then you tab this information with the items, low reading demand items, medium reading demand items, and high reading demand items. And then the numbers in the vertical axis are the percentage of students who got, in average, these items correct. So you can see that for the low reading demand items, the strong readers, the circles, got 66% of these items, they got them correct. For the medium demand, 63% they got them correct. And for the high demand, 66 they got them correct. So what can you tell from that? You can say that when they are strong readers, when they are good readers, it doesn't make much of a difference if the item is a low reading demand, medium reading demand, high reading demand. Doesn't make much difference. They perform very similarly. And this is again the international average. But when they are poor readers, the squares, you can see that in general, the poor readers perform lower than the strong readers. No, this is in general, and this is clear, and this is expected, because poor readers are also poor students in general. No? Strong students are strong in most subjects. No? But the interesting thing here is to see that the lower reading tercile do much better in the low reading demand items than in the high reading demand items. So there is a trend. For when you are a strong reader, doesn't matter what kind of reading demands the items have. But when you are a poor reader, it does matter. So it has an impact on the scores in mathematics and science. What you can see here, the 27, is the difference between the strong readers and the poor readers in the low reading demand items. The difference is 27. The difference in the high reading demand items is 32, which is bigger. If the reading ability would not have an impact on mathematics achievement, then this 27 would be 27 at the end of in the third column. No? It wouldn't be differences, but there are differences. And when they have an asterisk, that means that these differences are significant. So the less skilled readers perform relatively better in low reading demand items, and on the other hand, or the opposite, the more skilled readers perform similarly in all kinds of items. It doesn't matter for them. This is just an example of some other countries, because this if you check the report, which by the way is available online and is free of charge, you can check the international average, but also you can check this graph for all the countries that participated. This is just an example, and I wanted to show you this one because there's Poland included in this graph. No? You can see that in Norway, the difference is big. In Oman, for example, interestingly, the difference is significant, but it's very small. So there is not much of a difference in Oman. The impact is not so high in Oman, for example. In Portugal, also there is a slight difference, but it's still there. In Poland there is a significant difference, but there is a kind of strange pattern in the middle, because for the medium reading demand items, the poor readers perform better than with the easy ones, which is not something to be identified. Why is the reason of that? No? So let's go to the third chapter of this book, which is the effective schools in mathematics, science and reading. This chapter examines how school effectiveness indicators work in different countries and for the 3 subjects. As I said, they took a theoretical model from the literature, they applied the same model to different countries, and they applied the same model to different outcomes, namely to mathematics, reading, and science. For this publication, an effective school is defined as the one that has a positive effect on learning for their students, independent of the effect of the background of the home. And this is what I was talking about before. No? You cannot compare, you cannot say this school is better than this school just because they got a higher score, because this higher score could be dependent or could be due different reasons. It could be that this is the school that performed better, have better students. It could be that this school has a library just next door where students can go and benefit from. It could be many reasons. So what you want to do in order to make this is the idea behind, to make a fair comparison of schools, is to discount all those factors that the school is not responsible for, that the school cannot change. School cannot change the level of education of the parents of the students that attend the school. The teachers, the principal cannot do anything about it. In some countries, and this is the case when the students are so poor that they don't have money to eat every day, and they go to school and they are hungry, school cannot do much about it. Even if you have the best teacher, even if you have the best disposition, even if you have a very well-equipped school, if the students are hungry, they are not going to concentrate and they won't learn. No? School cannot do much if the students, which, as it is the case in many countries, have to walk 3 hours to go to school every day and then come back 3 hours. School cannot do much if the students have to get up at 4 o'clock in the morning to work in the fields and then at 8 be at school working and studying. School cannot do anything about many things. So it wouldn't be fair to compare the school where the students have to work at 4 a.m. in the morning for 4 hours before going to school and they don't have breakfast. And of course this school is going to perform worse than the school which is in an urban, well-resourced area where students, the only thing that they have to do is to study and they have extra school activities after school and they have an easier life, let's put it like that. No? So you want to discount the effect of all these things in order to make a fair comparison. So this is what we do. And for that there are models in the literature. They tell you what to discount, how to measure, and how to discount it, and what is important. No? And for that, there's also a very popular technique, which are multi-level models. This is what they used in this chapter. Multi-level models, that means that they take students in the first level and schools in the second level, and for each country. There's one model for each country. So this is the model. This is what they found in the literature, and this is what they applied. You have control variables. This is the things that you are going to discount, that you are not interested in. That you know that are important, but want to discount the effect of them. You want to control for them. And those are the resources for learning at home, which is a variable that I was talking about before. This is the level of education of the parents. This is the number of books at home. And this is also if they have a computer and they have their own room. We don't want to take into account the effect of those variables when we run our models. In other words, or put it in different words, it could be what would be the score of the students if all of them had parents with the same level of education, if all of them had the same number of books at home, if all of them had their own room, and if all of them had a computer. What would be the score? This is what you do with the model. When you control for a variable, this is, or a set of variables, this is what you do. What would be the score if everyone had the same in these variables? And then also in the model you have analysis variables. The analysis variables are the things that are known as the school effectiveness factors. And those are things that the school or the policy makers can modify. So we want to know if these characteristics are important or they have an influence, they are associated to achievement, and if they are, we want to know to what extent, and we want to know because we can do something about it. We cannot do something about the home resources for learning, but we certainly can do something about promoting a safe and ordered atmosphere in the school, It's something that the school can do, something that policymakers can contribute to. We certainly can support for academic success. We certainly can do something about it. No? If we know what kind of things have to be done for promoting academic success, we can do them. This is something that teachers can do, principals can do, parents can do. This is something that can be done in the school. We want to know whether to have an adequate infrastructure in the school plays a role, because it's something that policymakers can modify. It's amenable to policy. We want to know if having well-prepared teachers has an impact, is associated with performance in mathematics, reading, and science, because we can modify the preparation of the teachers. And we want to know whether having well-equipped classrooms plays a role, and we want to know whether providing an effective instruction plays a role. And all of these things, we want to know them after we control for the home resources for learning and for the early reading and mathematics skills. We want to know if this plays a role even after controlling for that. I didn't talk about the early reading and mathematics skills. This is what they could do about reading and mathematics before they come to school. And we want to discount that as well, because this is nothing that the school can do. Remember that we are talking about effective schools. So we are talking about things that the school can change in order to be effective. They cannot change what the children knew before they came to the school. So that's why we want to control for those variables. So this is a very, very summarized, simplified way of putting it. If you look at the report, it has tables and tables with each of those factors, each of those variables and their regression coefficient and the variance explained by each level in every country, and so on and so forth. In this case, the only thing that I'm putting here is the effectiveness factors, which are the ones that we are interested in. The number of countries where this factor was significant or plays a role or is associated to better achievement in at least one subject, for mathematics or for reading or for science, at least in one. And then in the second column, I have the number of countries where this specific factor was significant in all the three subjects. The first effectiveness factor is safe and order. Safe and order climate, safe and orderly atmosphere. This is the most important factor. We can say that across countries, at least in 16 countries, it was significant. So it was significant in a good proportion of the countries. And it was significant for the three subjects in 7 countries. The other factor was support for academic success. It's also an important one. It was significant in 10 countries in at least one subject, and in 2 countries in the 3 subjects. Adequate infrastructure is 3 and 1. Lecture emphasis, this is about effective instruction in 1 country only, and motivated students was, to have motivated students was significant at least in 1 country, at least in 1 subject in 13 countries, and in all 3 subjects in 5 countries. So as you can see, not all what we hypothesized, not all what was in the literature actually plays a role when you apply it to across countries and across subjects. Those factors that are important for improving or that are positively associated with academic achievement in the 3 subjects. The most important one, as I was explaining in the previous slide, is to have safe and ordered schools, safe and organized schools. This is important, and this is important across countries, this is important across subjects. What exactly does it mean? Because I have been telling you about concepts, about things, but we don't know what exactly does it mean. It means to maintain good discipline, or let's put it in another way. The schools that are considered to be safe and ordered are the schools that maintain good discipline, are the schools that are safe and organized, are the schools that reduce bullying frequencies between students. If a school has these 3 characteristics, we can say, or we considered, according to the framework of this study, that this is a safe and ordered school. The second was the support schools. The effective schools are those which support academic success. And the schools that support academic success have teachers who understand the curriculum goals, teachers who implement the curriculum and have high academic expectations of their students. The schools that support academic success have parents who support the academic success of the student, parents who help and are involved in the school activities of their children, and students who desire or who wish to be successful in school. And this is a very interesting variable because this has a holistic view. No? Schools that promote academic success is not only responsibility of the principals, it's not only responsibility of the teachers, or not only responsibility of the students, it's the group of them working together, doing the things that are listed here. When you can consider, you can have, or you can consider that this school is supporting academic success. When these three actors work together towards the education of the children, then it happens that we have a school that is supporting academic success, and it happens that these schools are performing significantly better in many countries than the schools that not have these characteristics. And then we have another variable that resulted to be very important, which is motivated students. Who are the motivated students? It's easy to say, no, but we have to define it. When can we say that a student is motivated? Is this when they are motivated, when they know what is required of them, what is expected from them? They are motivated when they enjoy what they are reading, in the case of reading, literacy. They are motivated when they feel it is easy to understand their teachers. They are motivated when they believe that their teachers present the content in an interesting way. And they are motivated when they believe that their teachers assign them interesting tasks. So how can a teacher have motivated students? Is that they don't come motivated from school, that you have to motivate them. No? How? This is the way how. No, this is the finding, again, across many countries, across different subjects. I mean, there are many people, many thousands of children and teachers were asked how to be motivated, and this is what they said. Finally, let's go to the last part, which is some examples for schools, and this is the released items. I already told you in the brief examples that I was giving about what schools and what principals, what teachers are doing in Armenia. I think it was the case. They are using the released items. I told you also that in Spain they are doing it. In the US they were doing it. I'm very sure this is like at the system level, no? But I'm very sure that around the world there are many teachers who are already doing it. And this can be very, very useful, no? How can the teachers or the principals or even the parents use the released items? It can be, they can be used in different ways. They can use them to design evaluations on specific processes, such as processes for reading comprehension. For example, you can say reading. Well, what is reading? Of course, there is a framework for the student, no? that defines what is reading. But they say that there are different processes in reading. And the processes are to make direct inferences, to locate and obtain explicit information, or to interpret and integrate ideas and information. When we have the release items, we are telling which item is measuring what. We say this item is a reading item, but this item is measuring whether students can make direct inferences, whether the students can locate explicit information, or whether students can interpret and integrate ideas and information. So you can select only the released items that you have there that are evaluating, interpreting and integrating ideas and information, and apply it to your students and see whether they can do it. Or they can practice with it as an exercise for them to do it and to learn it. The teacher can also give the items to the students and grade them using the corresponding guides. We give the items, the questions, but of course we tell people which are the correct answers. Also, there are some constructed response answers where the students have to write a text to answer, and we have the scoring guides to guide and to tell teacher when an answer can be considered correct or incorrect, or partially correct. The teacher can even compare the percentage of students who responded correctly with the international average. Because then you can say, okay, in my classroom, 90% of my students responded this item correctly. And we have the information that tells you in the world what percentage of students responded this item correctly, or in particular countries. In this country, that percentage of the students responded this item correctly. And then that can help teachers or principals to have an idea where are their teachers. You can compare with your national average. You can say, my students had this item correct in a higher proportion than the national average. They can also use them to give feedback to get feedback on the teaching and learning process. When they apply these tests and they mark them, and they have the different areas in reading, as I was saying, retrieving explicit information or interpreting information, they can know where they are not doing so good as a teacher. My students are weak in this area. So I have to reinforce, I have to review this particular content or this particular kind of exercises. They can use these items to understand misunderstandings or confusions. The teacher can analyze incorrect or partially correct answers in its class to understand possible confusion and reinforce a specific topic. Same thing, no? You can analyze, of course, the correct answers, but you cannot analyze the incorrect answers. Because if you check the incorrect answers and let's put it that way, all the students got it wrong in the same way, then you can see where is the misunderstanding. You can also identify individual difficulties. In this case, you can give a grade to each student, and you can see that, of course, for my whole classroom or for my whole school, retrieving particular information is a problem. But it can be, of course, and it will be the case that for particular students, this is not a problem at all, but they have problems in other areas. And then you can plan remedial actions based on this information. So this is an example of a released item. This is called the enemy pie, but there is a text, 500 words, 800 words text that they have to read. And after they read the text, they have several questions. This is just one question. And the question is, at dinner, why did Tom begin to think he and his dad should forget about the enemy pie? And then you have to interpret why. It doesn't say, when you read the text, I don't have it here, but when you read the text, it doesn't say Tom and his dad thought they should forget about enemy pie because it doesn't say it like that. It's embedded in the text. So they have to interpret. No? And then you say, because Tom did not want to share dessert with Jeremy, because Tom did not think enemy pie would work, because Tom was beginning to like Jeremy, because Tom wanted to keep enemy pie a secret. And then the right answer is the one with the star. And then you can apply this to your students, or teachers can apply this to their students and see what percentage of their students got it correct, and then they can compare. Like with the international average, they can compare with that, and they can say, for example, 60% of my students got it correct. That means that we are at the level of the Czech Republic. Or we did it, only 10% got it correct, so we are worse than the worst country. This kind of references, this is just for references purposes. This is another example about mathematics, and this is Susan has the 6 pieces of cardboard shown above. Which of the following shapes could Susan make using all 6 of these pieces without cutting them? And then this is a slightly more complicated one, and this is the one that she can make. We have another one for science, which is Maria designed an experiment using salt and water. The result of her experiment are shown in the table. And then what is Maria studying in the experiment? And then how much salt is dissolved, how much salt will dissolve at different temperatures. So they have to make sense of the table, and then they have to reply. And same thing. Finally, this is I will circulate the presentation if you want it, but this is just the references to the reports, to the publications that I was talking about. You can find much more information about what we do in the IEA in these web addresses. The IEA.nl, this is the address for the headquarters in the Netherlands, that's why it's the NL. The IEA DPC, this is the web address for the Data Processing and Research Center, which is in Germany, that's why it's DE. And we also have a Facebook account. If you're into Facebook, we have a Facebook account for the IEA RANDA. RANDA stands for Research and Analysis Unit. And we have this Facebook account in which we are announcing when we are having trainings, what countries, in what dates. We give many trainings in academic conferences, international conferences, so we are announcing there. We give some trainings, like 1-week trainings in Hamburg, This year we're going to have one in Hamburg, very similar to what I'm going to be presenting later on in this visit. We're going to have one in Hamburg, and we're going to have another one for Asian people in Malaysia. We also post information about job positions, about scholarships, about calls for papers. When we have new publications, we put it there, and so on and so forth. So it can be interesting for you if you're interested in these topics. And that was it. Thank you very much.